In the earlier parts of this CS1033 Programming Fundamentals course module, you have learned how to program a computer. You have done some programming using a programming language called Python. You have also learned how you can use computers to solve problems, how you define a problem in terms of an algorithm, and then write a program in Python programming language to implement that algorithm. In this part of the course, we are looking at computers from a different perspective. We are going to see how these programs that you run, right, can really run on the computer. What happens inside a computer when you click on that run button, how the computer actually execute this program and bring the results that you are expecting. In order to understand this topic very clearly, we will be looking at why a computer is called a computer, and a brief history of how computers were some years ago and how they look like today. We'll also look at how different parts of a computer are logically connected to each other, logically organized inside the machine to perform its expected functions. So far, you have learned about how to program a computer, which means you have looked at a computer from a programmer's point of view. But if you are building a computer, you have to look at the computer from a hardware engineer's point of view. So we will look at two different models of a computer, the programmer's model and also the hardware model. Then we will also know that the computers are built using digital circuits, and computers can do process data. So eventually these digital circuits do processing data. So we will see how we can build digital circuits that can process data. Then we will see how these digital circuits that process data can be formed in terms of instructions that can include in a computer program. More specifically, we will look at how the central processing unit of a computer, which is responsible for all program execution or data processing tasks, can be implemented using this type of circuits that can process data. So we look at the CPU instructions in a computer. Then we will see how the CPU itself is constructed. What are the parts inside the CPU, and how they work together, and how they are organized inside the CPU to function as a computer. Then finally, we will take a very small program and walk through that to see how the different statements, different instructions in that program are really executed in a CPU. I hope that this course is going to be very interesting to you. Unlike the other parts of the course, I am going to describe these aspects using an animated video series. There are a number of parts in these videos which I hope that you will download and go through in the specified order to understand the story behind how a computer would work. About 60 years ago, when NASA in United States started their space program, they had to design new spaceships. They had to design spaceships that could take someone from Earth to outer space or to a different planet even, and bring them back safely and without any problems. The design of these spaceships has to be modeled completely in the mathematical domain and the engineering domain. It was not possible to do a trial and error test. So they depend on calculations. They depend on equations, very complex equations that had hundreds and hundreds of parameters and thousands of data points. Now, engineers in NASA knew how to come up with these equations. They were even able to find algorithms for solving those things. But there had to be someone who could take those equations, substitute them with numerical values, and calculate the answers. That was a tedious process. That was a process that would require people with a lot of skills in mathematics. To solve this problem, NASA set up a separate division called the computing group. And there was one such unit called the West Computing Group, which played a very pioneering role in the space program. This West Computing Group had about 50 computers working within the department, but none of them were machines. They were humans. They were called computers because they had the talent and the skills that is required to do computations much faster and much accurately than an average person. When engineers came up with an equation, they went to one of these computers, a person, and told them how to solve the equation, told them the method of solving the equation. After that, the computer would take it and then substitute those values in the equation with whatever the data that is required and came up with answers accurately and very quickly than the engineer himself. There's a very nice movie called Hidden Figures. The movie is about three African American ladies who pioneered the West Computing Group, and they were very instrumental in sending the first man to the moon and bringing him back without any technical faults. The movie is available on the internet. I would advise you to have a look at the movie if you have time. Of course, with time, the human computers were replaced with machines. Machines like the IBM 1130, a huge and the state-of-art computer available at that time. Now, even with these computing machines, the engineers have still to come up with the equation and tell the machine how to solve the equation. For that, they use a programming language called Fortran, which stands for Formula Translator. Using programs written in Fortran, these computers were able to follow the exact steps given and solve these equations at the same accuracy as a human computer would do, but at a much faster rate. In the early days, computers were mostly used for scientific purposes, do large number crunching operations. They were also used in business domain to sort and order large volumes of data. From that time, computers have come a long way until today's time. Today, computers are almost part of our everyday life. Most of the time, we even use computers without knowing that we are using a computer. Today's computers also appear in different forms. Most of the commonly used computers include the desktop computers, the notebook computers, the convertible laptops, which function as a notebook as well as tablet computers, then tablet computers themselves, and finally smartphones. Apart from these things, there are also many other equipment that are provided with computers, but we use them without knowing that we are dealing with a computer. For example, most of your household equipment like the television, the audio setup, the refrigerator, the washing machine, or even a remote control fan is likely to have a computer inside that helping the device to function properly. Now, these computers are sometimes called hidden computers or more commonly as embedded systems. These systems reside inside some other device and help that device to operate properly. It reads various inputs from the sensors attached to the device and then produce the required signals so that the device can function in a smart way and also more efficient way compared to their traditional counterparts. A recent survey has shown that on average there are about 25 to 50 computers in an average household. If you look around and if you look at most of the equipment that we are using today, if it has a soft start stop button, if it has one or two buttons which provide more than one functionality, then it's likely to have an embedded computer inside there. And also if you take modern automobiles, cars for example, has about 50 computers controlling different part of the vehicle. There will be one computer controlling the engine, there will be another one controlling the brakes, there will be another one controlling the steering, and there will be another one controlling the safety systems like the airbags, etc. So today's world is driven by computers. That also makes it very important for us to know how these computers work, because if they go wrong, the results can be disastrous.